free expansion and isothermal process. So what is free expansion? Free expansion is that expansion when the outside pressure is zero. Means we are doing expansion in vacuum. So expansion of gas in vacuum, that is external pressure is zero, is known as free expansion. Means there is no blocking agency, there is no blocking agent outside. So that's why we say it is free to move, free expansion. No work is done during free expansion. This is slightly tricky to understand. You might think that because piston is moving, there is some work being done, but in physics, it is zero. The reason is the work is given by minus P external delta V. So although change in volume is taking place, but P external is zero because it is vacuum, so it will be zero. So work done in free expansion will always be zero. Then isothermal process. Isothermal, iso means same, thermal means related to temperature. So same temperature. Temperature does not change during the process. That is known as isothermal process. So Joule experimentally determined that for isothermal process, the change in internal energy is zero. So remember, isothermal process, delta U is zero. Hence for isothermal process, first law of thermodynamics gives us Q plus W will be zero. If Q plus W is zero, Q will be equal to minus W. So whatever formula you have for work, you can apply for heat in case of isothermal process only. Remember, these formulas will be applicable only for isothermal processes. Whatever is written here, few important formula I am talking about. For isothermal irreversible change, Q will be equal to minus W, and W you knew. W is minus Px delta V. So minus and minus will give you plus. So that's why Q will be P external into delta V. Only applicable in case of isothermal process. Okay. Then isothermal reversible process. In this case, there will be integration. If you solve the integration, it will be 2.303 log something. Okay. So I will be using Q equals to minus W. It is isothermal process. Delta U will be 0. So that's why Q will be equals to 2.303 nRT log Vf by Vi. Why? Because in this case, W is minus 2.303 nRT log V final divided by Vi. This minus and this minus will be plus. So that's why positive sign. Sometimes I have seen students making mistakes using negative sign here. Okay, remember, negative sign is only in the formula of work. Okay, not in any other formula we will be using in this chapter. Okay, apart from one I will be using for Gibbs energy towards last of the chapter, there will be negative sign. But here whatever we are talking about, internal energy, external energy, heat enthalpy, okay, work done, energy, whatever, only the work formula has a negative sign. Although the answer can be negative or positive, right? I'm not talking about answer. Answer can be negative if the work is done by the system. Answer can be negative if heat is evolved from the system. Okay. I'm talking about formula only. For adiabatic change, Q is 0. Okay. So for adiabatic change, we know that heat transfer will be 0. And if it is heat transfer 0, delta U will give you W adiabatic. So these formulas I will be using, you need to remember. The question: 2 liters of an ideal gas, initial volume 2 liters, at pressure of 10 atm, so pressure is 10 atm, expands isothermally. If it is isothermal process, delta U is 0. At 25 degrees Celsius means temperature is 298 Kelvin. In a vacuum, okay, so it was actually P initial, internal. Vacuum means P external is 0 here. Till the total volume is 10 liters means V final is 10 liters. Question is how much heat is absorbed and how much work is done in the expansion. So first we can calculate the work done. work done, because it is isothermal, obviously I can calculate the heat later on by minus W by using this formula. For isothermal process, delta U is 0, that is Q equals to minus W. But work can be obtained by minus P external delta V. And remember, it is vacuum outside, P external is 0. It means it will be minus 0 multiplied by delta V. Delta V will be final pressure, final volume minus initial volume. So it will be 0 into 8, that is 0. No work done. If no work done, obviously Q equals to minus W, that will also be 0. Isothermal process. So no work will be done, no heat will be done. So we have Q equals to minus W, W is minus Px delta V, which will be 0. So no work done, no heat absorbed. Next part of the same question. Now consider the same expansion, but this time against a constant external pressure of 1 atm. So we will apply the same formula. Q equals to minus W, because delta U is 0, it is isothermal process, Q will be equal to minus W. And here we will apply the same formula, minus P external delta V, but now P external is not 0, it is 1 atm. So we will substitute these values. P external is 1 atm and V final minus V initial will be 8. So answer in this case will be 8 liter atm. So if we say W, W will obviously be here in this case minus 8, okay, because W will be minus P external V final minus V initial. So it will be minus 1, 10 minus 2, that is minus 8 atm liter or liter atm. And it is negative. It means it is done by the system. Okay, this is plus, it means absorbed by the system. This much heat absorbed by the system. Positive on the system, to the system. Okay, negative done by the system, from the system. Next part of the same question. Consider the same expansion, but we have now 1 mole. So N is given. Ideal gas conducted reversibly. So if it is reversible, you know the formula is integration formula, or 2.303 log V final by V initial. Obviously nRT will be there. So we will use that formula. It is isothermal. Q will be equal to minus W, and W here, if you remember, for isothermal process, reversible process, it was minus 2.303 nRT log V final divided by V initial. So minus and minus will get neutralized. So you will have 2.303 nRT log V final by V initial. Substitute all the values. We have 1 mole here. Substitute N equals to 1. R we have taken 0.0821. It means our answer will be in terms of atm and liter. So this value of gas constant, the unit is atm liter per Kelvin per mole. So it means this Q we will get in liter atm or atm liter if we use this value. If we use 0.0831, it will be liter bar in that case. Okay, if we use 8.314, then it will be joules. So depending on what unit you want as result, you need to take the value of R accordingly. Then we solve this one. Log 5 value is given. So substituting that, we solve, we get the value of heat as plus 393.66 liter atm. And because it is positive, it means this much heat will be absorbed and the same amount of work will be done by the system. W will obviously be negative because Q equals to minus W.